Hello, we are Team 17, and for our Spring 2023 Senior Design 2 project, we've created a solar-powered tailgate drink cart.
I'll start out with our problem definition and description. We were tasked with design and building a project that would leverage all of our knowledge and skills gained at Clemson. This semester, we were faced with many challenges, including designing systems that we were not familiar with and purchasing and acquiring materials from several vendors. For this project, we decided to create a solar powered tailgate drink cart. The thought behind this project was that we would create essentially a vending machine on wheels, which we accomplished. The only difference between our final design and the product that we created is that we wanted the cart to be driven using motors and chains. However, we were unable to make that happen with our time limitations. Now for our motivation. The motivation for this project is to try to create a modular vending machine system that can be used in remote locations and operate using solar powers. We decided to make the system mobile with wheels so it can reach those more remote locations and be battery powered with solar panels to be able to function in areas that don't have access to power.
For our design solution, we wanted to go with a modular design. This would allow for future customization, like a drink fountain or something of that sort. And so for that, that allowed us to break each part up and have it where each part could be made separately and then put together into the final product. And so we split that into four main parts: the frame, motor, and solar panel setup. That was going to be the basis for the whole project. The vending apparatus, the cooling apparatus, and then the HMI and Android applications that would be coded separately with the Raspberry Pi.
So, in terms of the cooling, as we can see, two of the strengths are that it's able to keep drinks at a desirable drinking temperature, and it pumps ice water through the radiator while fans blow air through the radiator. We're able to do this by utilizing an old heater core off of a 1965 Mustang and attach two 12-volt DC fans onto it. We then took clear tubing into the cooler that is set right beside the vending box and attached the tubing to a 12-volt DC bilge pump that is submerged in ice water. So as the pump pumps the water through the radiator, the fans blow air over the cold water and into the vending box, keeping the drinks chilled. Couple weaknesses with this though is that condensation builds up on the hoses, but we're hoping to fix that with insulation that has been acquired and will be put on the hoses. And the radiator also condensates. In order to fix this, we're going to put a towel underneath to try and catch some of the water dripping. And then also because you're pumping the air through the sorry, because you're pumping the water through the exposed air, it latches onto some of that heat and heats up and it melts the ice rather quickly. Hopefully this will be mediated by putting insulation on the hoses though.
As you can see in this video, at the flip of a switch, this turns on our pump, as well as the fans, which cycles cold water throughout our system.
For the solar and battery system, we used a 100-watt solar panel that is affixed to the top of the cart. This goes to four 12-volt DC lithium-ion batteries that are wired up in parallel. Couple strengths of this is that we're able to charge the batteries in about 5 hours. Ideally, it would be 4.5, but upon testing, we were able to get it to maintain a voltage and a current that would charge the batteries from completely dead to completely full in about 5.1 hours. A good thing about this panel, though, is that it's rated to be able to maintain the system without the batteries. As we all know, with solar panels, though, that may not be the case. Say it's cloudy outside, so the batteries are a good backup in case it is cloudy or rainy outside. Couple weaknesses with this system is that right now the wiring situation is not beautiful. That is being addressed and will be taken care of. And only some of the batteries have proper hardware for wiring. This is how they were given to us, and we had to makeshift some of the terminals, but we are using the proper terminals for actually wiring the system.
For our vending subsystem, the strengths are that it's able to store a large number of drinks. It can store 12 cans per lane and 36 cans total. It utilizes a gravity-fed system to dispense the cans, and the dispensing can be done with simple servo movements. And additionally, few inputs are required. There's a demultiplexer circuit built in that lets 4 input wires control all 6 servos individually. The weaknesses are that it can only accommodate one standard drink size, and it also has more moving parts than a traditional vending machine, so there's more that could break down or need replaced in the future.
A human-machine interface for controlling the vending component of this cart was created using a graphical user interface on a 7-inch touchscreen. The touchscreen was connected directly to the Raspberry Pi and was located on the cart. This HMI provides live temperature readings that are updated every 2 seconds. When the user selects a drink option, all of the buttons are disabled while the vending operation is in progress. A downside to this is that the HMI operates independently of the Android application mentioned previously. This HMI also does not provide a live count of the drinks like the application does.
In this demo, the HMI operates the servos which dispense a drink. Shortly after a button is pressed, it rolls out ready to be picked up. As you can see in the video, after a button is pressed, it turns all of the other buttons gray, disabling the possibility of multiple touches. In total, it takes about 6 seconds to fully complete the cycle, and after each cycle, the next drink is primed and ready to be dispensed.
An Android app was created to be able to control the vending component of this cart remotely, and as long as the Raspberry Pi and Android device are on the same network, they're able to communicate over a relatively large distance compared to the Bluetooth connection that was considered previously. When the user selects one of the options for vending, the other buttons are disabled for 10 seconds while the vending operation is in progress. Some downsides to this application are that it operates independently of the HMI or the touchscreen controls on the card itself. This app does not provide much user feedback other than the button has been pressed, so if you're at a large distance you don't necessarily know that it has done anything. But the application does show how much stock is left of each of the items for the vending component.
Similar to the HMI, at the press of a button, it sends a signal to the Raspberry Pi, which initiates the dispensing cycle. The Android app also recreates the disabling of the buttons, in this case about 10 seconds, to also prevent multiple presses until the drink is completely dispensed. There's also a dialog button that pops up whenever a button is pressed, along with a count that decreases at every press.
So for the motor setup, we really wanted this to be a mobile apparatus. It was going to move kind of in the way that a tank would move. Each side that would move in unison, and then if we wanted to move left or right, one side would go in the reverse direction as the other, and it would turn left or right. That was going to be controlled by the Android app. So the mobility in a tailgate situation would have been nice to have, and it was supposed to be sturdy enough to hold all the weight. What we ran into was the motors were not strong enough, didn't have enough torque to actually move the whole project. The sprockets began slipping in the chain. Even with a chain tensioner, we could not get it to move forward. Along with that, the wood that we chose for the bottom of the frame ended up being way softer than we thought. And so where we mounted the axles and wheels, the tension from the chain and the motor system ended up pulling those in, and we had to remedy that.
Now that we have looked at the various subsystems of this project and analyzed the strengths and weaknesses of each, we are going to get into our final design prototype with each subsystem all put together and working in conjunction. So the following video will consist of dispensing all 3 drink types with both methods of interaction and all of the systems enabled in their final state.
In our final design prototype, we are able to achieve dispensing of drinks either with the HMI or the app. They are both able to operate independently of each other. However, if one is dispensing, then the other system is unable to dispense a drink. The following slide contains our references that we used throughout our project.